Welcome, recruits, to this explainer. Today, we are taking on the ultimate aerospace challenge, which is designing a fully functional, survivable base on the surface of the moon. I am absolutely thrilled to guide you through this mission. Now, we aren't just talking about a quick weekend visit here. We're talking about long-term habitation. And pulling that off requires a perfect blend of science, technology, engineering, mathematics, and yes, even art. So let's dive right into exactly what it takes to build a home on the lunar surface.
Right out of the gate, we've got to ask this critical question. Could your crew actually survive the moon? The stakes for this mission are absolute. This isn't just some theoretical exercise. Your mission is to ensure the answer to this question is a resounding yes. Because up there, when you're facing drastic temperature swings from 250 degrees above zero down to over 200 degrees below zero, mistakes aren't just a bad grade. They literally mean mission failure. So here are our 4 mission-critical objectives for today. The Lunar Mission Challenge, engineering life in space, doing the space math, and finally, designing your lunar base.
Let's start with Objective 1, the Lunar Mission Challenge, assessing the environment.
Before we even think about building a single structure, we have to gather our intel. First up, you need to establish your identity, so decide on a lunar base name for your team. Next, determine the exact number of crew members your base is going to house. This is absolutely crucial because this single decision impacts literally every other variable. And finally, you have to review the actual lunar environment to understand what you're up against. You simply cannot design a solution until you intimately understand the problem. And in this case, the problem includes things like extreme radiation and the cold, hard vacuum of space.
Once you know what you're up against, your team will dive into the science and technology required to understand how a lunar base actually operates and supports life. You see, it's one thing to build a strong airtight box. It's an entirely different beast to create a closed-loop system. To survive, you'll need to explore the science of how a base functions day to day. Think about how current astronauts on the ISS are literally recycling their own breath and sweat into breathable air and drinking water. That's the level of engineering we're talking about here.
Which brings us to Objective 2, engineering life in space, focusing on systems and structures.
So, what exactly are we engineering? We are engineering lunar systems. These are the structural parts and engineering mechanisms required to let people live safely in space. We're talking about critical, non-negotiable life support. If you don't engineer these structural parts flawlessly to withstand things like micrometeorite impacts, well, nothing else really matters, does it? The engineering dictates the safety of your entire crew.
Moving right along to Objective 3, doing the space math and calculating your requirements.
Now in space, physical volume is your most precious and, frankly, most expensive commodity. Every single square foot must be strictly accounted for. To anchor our abstract math in reality, take a look at this number, 5,600. That is the exact square footage of living and working space currently available on the International Space Station. It gives us a highly accurate benchmark for what human beings actually require to operate in a microgravity or extraterrestrial environment over long periods of time. And this brilliantly illustrates the math challenge you're facing. To put it in perspective, that 5,600 square feet on the ISS is designed to hold a capacity of about 6 to 12 people. What I want you to do is compare that ISS capacity to the specific crew size your team decided on earlier. If 6 to 12 people need 5,600 square feet, what is your crew going to require? That ratio right there is the baseline for your space requirements.
To really wrap our heads around this, we've got an actionable mission activity for you. We need you to understand the physical area required for basic everyday functions. So, you're going to measure the size of the living spaces in your own home. Grab a tape measure and jot down the dimensions of your kitchen and dining area, your living room, your bedrooms, and your bathroom. By calculating the area of these everyday spaces, you'll really start to visualize what those numbers actually mean for human habitation.
So, here's the crucial point. Once you understand the area needed for each specific function, whether that's sleeping, eating, working, or sanitation, you will use mathematics to calculate the total area required for your entire lunar base. Believe it or not, your own home measurements are the mathematical key to determining the actual physical footprint of your lunar settlement. And finally, Objective 4, designing your lunar base with floor plans and models. We are synthesizing everything you've done into a clear checklist of deliverables. First, using those engineering skills, your team will draft the literal blueprints, a detailed floor plan for the whole base and for each individual structure within it. Second, utilizing your art skills, you'll create a poster showcasing a visual view of the base to effectively communicate your vision.
And third, bringing mathematics and engineering together, you will construct a physical 3D scale model. I really want to highlight this final requirement because it is absolutely the pinnacle of the project. You aren't just sketching ideas on paper here. You are utilizing all that math and engineering data to create a physical 3D scale model of the base exactly as it will appear on the moon. It takes everything you've learned about the harsh environment, the complex life support systems, and the calculated area, and brings the whole shebang into physical reality.
Which leaves us with one final thought-provoking question. What will your lunar legacy look like? You now have the objectives, the environmental constraints, the baseline math from the ISS, and the final deliverables you need to produce. You have the tools to design a settlement that not only survives the moon, but actually thrives on it. I absolutely cannot wait to see the bases you design. Good luck, recruits, and start building.